Now we are going to look at the composition of functions, which is a different operation than adding and subtracting. This little circle, f of g of x, really means we're taking g of x and putting it into f of x. I prefer writing it this way. It's more descriptive of what's going on. G of x is what we call the inside function, f of x is the outside function. So we take the entire function of g and put it into f. This looks like f of 3x plus 1. So we're taking 3x plus 1, which is g, and putting it into f. So when we do something with a function like this, we're going to take this value and put it in for all the instances for x in our function. So this is going to be 3x plus 1 squared minus 5 times 3x plus 1. Well, I know the FOIL of this is going to be 9x squared, and the way I've done this before, this is 6x plus 1. I distribute here, minus 15x minus 5. So all we would have to do now is combine like terms. And this equals 9x squared minus 9x minus 4. And that is f of g of x. Well, g of f of x is, I take f and plug it in for g. So this is x squared minus 5x. So it is 3, and then for this x I'll plug in x squared minus 5x plus 1. Distribute, this is 3x squared minus 15x plus 1. You will see that this one and this one are not the same. That is a thing that pops up over and over and over again. F of g of x does not equal g of f of x. If we're adding or subtracting, that's true. This operation of composition is not commutative. In other words, the order is important here. What if I wanted to do f of h of 4? Well, instead of doing f of h of x, I can literally just do what h of 4 is, and that gives me 4 minus 1 over 3, which is 3 over 3, which is 1. And I'm going to take this and plug it into f of 1, which is 1 squared minus 5 times 1, which is equal to 1 minus 5, which is negative 4. Another way to look at a composition is you're taking the output from one function, the inside function, and putting it into the second function. Can I do g of 7? Well, absolutely. I can take g of 7, and this is equal to 3 times 7 plus 1, which is 22. And then I take that and put it in again and do g of 22, and I get 3 times 22 plus 1, which is 67. Well, what about if we have h of g of x? Again, that means I'm taking g and putting it in to h. So I am doing, lost my place, h of 3x plus 1, which means I'm taking 3x plus 1 and plugging it in for the x and h, and subtracting 1 and dividing by 3. And this is 3x plus 1 minus 1, which is 3x divided by 3, which is actually just x. Well, let's look at it the other way. G of h of x, which is g of x minus 1 over 3, which is 3 times x minus 1 over 3 plus 1. Well, our 3's cancel, so this is x minus 1 plus 1, which is just x. Well, you notice in this case, f of g of x, or g of h of x and h of g of x are equal to each other. Up here I told you they're not. Well, I can't tell you that they are because they're not always equal. And sometimes they are equal. In this case, they're both equal to x. And we'll see in the next unit that in that case, h and h of x and g of x are inverse functions, which is our next unit.